Alright guys, welcome to the next alkyne video. So this time we're going to be covering how we can synthesize alkynes, right, given some sort of other reagents that we would be using. And so let's just get right into it. So how exactly are we going to synthesize these, right? So let's say we wanted to synthesize this sort of an alkyne. And again, this stuff could be useful for when you're doing synthesis reactions, stuff like that. So we have this sort of alkyne. Let me just make that easier. So we have here 1, 2, 3, 4. Right? So there are a couple ways that we can synthesize alkynes. So let's say we had this structure right here. This 4-carbon chain with BRs on opposite sides, right? And you guys know how to get this sort of thing. We can have this double bond. We can add Br2, and we would get a Br there and a Br there, right? So that's how we could end up starting with something like this. So how would we go now from here to there? Well, you can see that we have an alkane we're starting with, and we're getting to, we need to add essentially 2 double bonds. Oh, sorry, we need to essentially add 2 more bonds, right? So imagine that we're starting with this bond, and we need to get to this one and this one. So you guys know that elimination reactions are what end up forming double bonds. So we're going to do elimination reactions. So what are we going to use? Now, we're going to need a strong base. And so what we use when we're dealing with alkynes is something like Na, NH2. Na dissociates into Na+, it's a spectator ion, so it doesn't do anything. And we get NH2-. Now this is a very strong base. So what's going to happen is, let's get rid of the Na, so we can just see the NH2-, right? And what it's going to do is it's going to take an H off of a carbon with a bromine. So this is going to come in, grab the H, and what that's going to do is it's going to collapse down to kick this Br out, right? So similar to what you guys have seen, you're going to get this. Now notice this Br is not what was kicked off. Remember, when dealing with elimination reactions, you take a hydrogen adjacent to the carbon of the leaving group. So in this case, our leaving group was this bromine, not this bromine. Okay. Now remember, we always have more of that NaNH2 in the solution. So let me just lower this actually a little bit. So what we're going to do is we're going to have another NH2-. And now we're going to do another elimination reaction. But the question is, are we going to take an H from here, this red H, or from here? All right. So if we take that red hydrogen to do this, we're going to get this sort of structure. A carbon with 2 double bonds on it. That is super unstable. So we're not going to be forming this. Okay? What we're instead going to be forming is we're going to form the product of this elimination. And so now we're going to get a triple bond on carbon, say 1, 2, 3, and 4. So here's our triple bond. Here's carbon 2 and 3. Coming off of that is 4 and 1. So here's that, and there we go. That's our product. Okay? That's one way we can synthesize alkynes. And usually when we're dealing with this, you write something like this. So if we had Br, we write NaNH2 over excess because we use more than just one equivalent. All right? And then we get this. So you want to use excess, not just NaNH2. Another way we can synthesize this stuff is this compound right here. We can have halogens, 2 halogens on the same carbon. So what's going to happen is we're going to take an H from here. And again, you want to form the more substituted double bond, which is why we're taking the H from here instead of taking, let's say, this H from the get-go. So NaNH2 and I'm just going to write NH2 minus, grabs the H, brings that down and kicks this Br out. So we have our Br here that's left over and the double bond. And now again, we're going to want to take the H from here. That's going to come down, kick this guy out, and so bring that bond down to kick the Br out, giving us the same product. So we have two ways so far of synthesizing alkynes. We have two halogens on adjacent carbons. And we have if we have them on the same carbon. So both of these will give us this triple bond. And again, depending on what your what the substitution pattern is, right, where the bromines are, we can get other triple bonds. Okay. So, are there any other ways of synthesizing alkynes? Right. Well, this covers mainly the synthesis of alkynes, but what we can do is we can also extend our alkynes. Right. Again, more useful stuff for synthesis. So you guys have seen reagents when you learned SN1, SN2, E1, E2 stuff that look like this. So R group, but a minus charge on the alkyne carbon, reacting with a primary leaving group, like usually Br, chlorine, iodine, and it's going to perform an SN2 attack on that carbon. So now we're going to have this R here. And always you want to count your carbons, so we're going to have R group, I'll just count it as 1 so we don't lose track of it, 2, 3, 4, 5, 6. So here's our 1, 2, 3, 4, 5, 6. So how are we going to do this? Well, again, in this case, we're going to have to form this little nucleophile, all right? What we're going to need in this case is you're going to need a terminal alkyne. So let's just remove the R group and just put something there instead. Doesn't matter what it is. So here's our terminal alkyne, and remember, there is a carbon here and here. And off of that carbon, that terminal carbon, we have an H. Now you guys know that sp hybridized carbons, right, their H's are more acidic. They have more S character. So we're going to deprotonate it. And again, you just want to use a base, so NH2. We remove the Na, it becomes Na+, and we're going to get a minus charge here. And all it's going to do, it's going to just deprotonate this. And we're going to attack it, and then we're going to put a lone pair right there. Okay? And so that's going to be how we generate this nucleophile. Now, to extend the alkyne, you need to be careful. This is going to be SN2 based. So you're going to want a primary leaving group. So something like that works, right? Or maybe even like this. Or if you want to add a methyl by one, or extend by one carbon, we would do this. Be careful though. Remember, we have the exception of beta branching. So if we had something like this, right? Here's your alpha carbon, and that's the beta carbon right there. That's fully substituted beta branching. We're not going to be able to do that reaction, okay? Neither are we going to be able to do this on a secondary leaving group because this is a good base as well. So you could see this on your exam. We, use NaNH2 on that terminal alkyne, and we have this this nucleophile. This is called an acetylide. All right. And now let's say I have this compound. Remember that when we have a good base on and we're reacting with a secondary leaving group, right? What we're going to do is we're going to perform an E2. That's going to attack the H, bring that down, and kick this Br out. So instead of extending our alkyne, we're getting the E2 product, and what happens to our alkyne is we just got the H back. All right, so want to be careful with that. Always watch out from when you have to see what kind of product they're giving you. All right. Now there is another thing that we can do with acetylides. So let's say I have this acetylide right here, and we can react them with carbonyl groups. All right. So let's say I reacted it with this carbonyl. All right. So it's got two methyls on it. Oh, and here's our negative charge. What can happen is this is going to attack the carbon of that carbonyl, right? And remember, the reason carbonyl carbons are electrophilic, prone to getting attacked, is if we look at the resonance structure, which I'll draw in blue, that arrow, we're going to get a compound that looks like this. That carbocation, right, gives the carbon a partially positive character, which means it's a little bit more electrophilic, more prone to getting more attracted to negative charges, like that acetylide anion. So we're going to attack that carbon, kicks that guy out, and so we're going to get this weird looking product. Count your carbons always. 1, 2, 3, and we're reacting with that carbonyl carbon. 4. So here's a triple bond. 1, and let me just make this a little bigger. 2, 3. We're forming a bond to carbon 4. So here's carbon 4. Carbon 4 is now going to get an O-, and it had two methyls coming off of it. Here's one methyl, and here's another one. We can react it with something that gives a proton source, so like H2O. And our final product is going to look like this. All right, so usually you could maybe see this as like step 1 for the carbonyl, or let's rewrite it down here. Step 1, step 2, H2O. Right, so you could maybe see that in a multiple choice where they give you a couple of steps in a row, and they'll ask you pick the one that gives you the final product. Okay, so always watch out for that reaction as well. So in the next few videos, we'll be going over more alkyne stuff. So if you're a little bit confused on something here, please feel free to email me. Talk to the TAs, go to the CLC. They'll be glad to help you guys. And I will see you guys in the next video.